Now, we are imagining that this is part of our display monitor that we have zoomed in to analyze. And just imagine that this is the top left of the monitor, and in every character row we would have 80 characters. Prior to this lecture, we explained that every character would have one byte or one memory cell assigned to it, which specifies the character and also the position that that character should be drawn into. As an example, in here, this would be the location 0, 1, 2, and then we would have dot dot. What I mean by this is just imagine this. Imagine 0x41 is put in the memory cell 0, which means at the position 0 or the top leftmost character box, which is obviously this one, we should have the character A drawn. And we explain how this refresh memory would be connected to a character generator ROM alongside with some other bits which would eventually draw this character. Then we would have 0x42, obviously, because in the memory cell number 1, it means that it would be the next character. The reason that I put a dot 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 is because it means that in every character row, since we have 80 and these characters are in the second character row, and since we are assigning one byte to every character, therefore this location would be the location 80, then 81, then 82, and so on. We also explain how, alongside with some other bits, we would resolve the issue of the monitor scanning one line after the other. Those would be explained further in detail in the next lectures. In here, I just want to explain one thing, that this isn't actually the way that things are done. Instead, for every character, we would have 2 bytes or 2 memory cells assigned to it. 1 byte is what we refer to as the character code that we explained. It specifies which character and the position of each character depending on the address of the memory cell. The second byte, which would be put in here, would be the attribute of that character. The bits in the attribute byte are defined like this. It obviously would be 8 bits long. So this is bit number 0, 1, 2, 3, 4, 5, 6, and 7. The first 3 bits, the least significant 3 bits, would specify the foreground color. And then intensity and blink, I would explain them later. And then you would have these 3 bits which would specify the background color. And we explained how using the RGB we could have any color that we want. I want to give you some examples. Let's say that we would have 0, 0, 0, and then 1, 1, 1. In here, we would have any values. Let's just imagine these two would be zeros. It means that in this character, we would have 0, 7 in hex, obviously. All these values are in hex, except the addresses. In addresses, I have shown them in the decimal. So if you have 0, 7 in the graphic card, they would eventually do this, they would say they would be defined. As I said, in the architecture, I would explain how these bits are created one by one, or in the monitor, how the monitor would treat them. But let's imagine that the definition are exactly based on what I'm showing in here. So it means the background color should be black and the foreground color should be white. And since 40x41 is saying that the character should be A at the position 0, which means the top left, it means in the first character, the background would be black and the foreground would be this. So we would have A in the first one. As an example here, we would have A and the background would actually be black, which in this case is, as I said, the borders are not real. So instead of green, we would have a white. As another example, let's say for the 0x42, let's say that we would have 0, 1, 0, 0, 0, and in here for these 3 bits, we would have 1, 0, 0. So let me actually wipe this thing out so you should better see them. Let's imagine that in the memory location 3, we would have 0, 0, 1, 0, 0, 1, 0, 0. So in hex, this is obviously 4 and this is 2. So you would have 0x24, or obviously the value 0, 0, 1, 0, 0, 1, 0, 0 in this memory location. just because I don't have a space. I'm writing things in the hexadecimal. So what this means is that the foreground color should be red because we only have red equal to 1, and the background color should be green. So in the position number 2, meaning that in this position, if you are imagining that this location is the top left, B would be drawn because of the 0x42 at the location 2, but it would be drawn in this way. So we would have only G equal to 1, which means you would have green. So if the background color, and just imagine, actually we would have green, the color just changed. So we would have only green. The character box, imagine that this is the length of the character box, exactly equal to this, okay? So this would be the character box, and the foreground color, we would have only red equal to 1, and therefore B would be drawn. So B would be like this. Actually, it's, yeah, with the, again, you would have only red, we would have B. So on the display, the color, the background and foreground color would cause that we would have this one in this location, which is the second location in the first character row. And then the other bits would be also defined. So what I'm saying in here is that the graphic card was designed in such a way that it would be able to work with the monitors that have a definition for the RGB that could work with any color. Now, if a monitor couldn't work with any color, the graphic card or the monitor were made in such a way that these 3 bits alongside with these 3 bits would be most often ignored. I say most often because only 4 combinations of these two would be used, and I explain what those 4 combinations are. But the only bits that had a meaning for that monitor would be intensity and blink. Now, I will be explaining the type of different monitors later in the course, but the only 2 bits that would have a definition would be intensity and blink. Let me first explain what the blink is. Let's say that you want to design a graphic card that would tell the monitor to blink a character. How would you make this character to blink? Well, obviously, you would want that at some portion of the time we would have A in here based on the character code in the character generator. But then some time later you would want for all the pixels in this character box only the background color to be shown. So first we would have, just imagine the tablet in here as the obviously as the background, which is black. So at some portion in time we would have A, and then some other portion in time we would have again background color, which would again means that we wouldn't have anything. We would only have black. So you see, at some portion of time the foreground color would be issued by the monitor, which result would be that us having green on the black background. And some other portion in time, obviously the foreground color would be added. So only for these pixels that are obviously specified using the character generator ROM, at some point the display, the monitor would put the foreground color resulting on the drawing of this character in the character box. And some other point in time, all the pixels in the character box, including these pixels, wouldn't have any foreground color, and only background color would be added, which would result in seeing nothing in here. And then again, it would change to having the foreground color on the aforementioned pixels, and therefore it would have A again. And this gives us the processing of seeing a character blinking. Obviously the timing would be in our hands, that could be somewhat controlled. So lastly, we want to talk about the intensity. So the way that the intensity bit would work is like this, that some monitors, we previously explained that some monitors would have one video pin, and depending on the value on the video pin given to that monitor, we would have either the background color, it would be the black color, or we would have the foreground color, which would be green. But in fact, those monitors would have 2 pins or bits assigned to them. One of them would be video and the other would be intensity. I will be showing this to you in the next lectures. So depending on the values on the zero, on the video and intensity, we would have 4 different colors. You could understand why we would have such a thing, because it gives us more color. It gives us 4 different colors. So if you would have 0, 0 on the video and intensity, the monitor would only show black. If you would have 0, 1 dark green and then 1, 0, you would have green, and light green, you would have 1, 1 on the video and intensity. Now you might ask, well, what if, since this graphic card was created for different monitors, what if the monitor could show the values of RGB, but it also has, what would be the definition of intensity then? Well, you could imagine that having the intensity bit, it would increase the number of colors that we could have for every character. So in a monitor that we only have video and intensity bit, video pin would be created differently. That would be explained later as well, even though I think you have some understanding based on what I have explained in the previous lecture about creating an imaginary graphic card in our mind. I believe this would be, if you don't understand these things, it's okay, even though I don't think it was that complicated. In the next lecture, we want to analyze different monitors. How is it that we say some monitors could have RGB and some monitors can't? What is important is that in the architecture of the first graphic card, different scenarios or different functionalities have been implemented so they could work with different monitors.